Okay, so moving on then, how else can we construct data? Well, another way that we can construct data is by looking at certain pinch points or certain sort of points in the data that will tell us some interesting things to describe, for example, the spread. Okay? So on the screen, I have got temperatures from 2 holiday resorts. So I've got resort A on the top and resort B on the bottom. And then I've got the temperatures on 10 consecutive days, I think I've said, in 2 separate holiday resorts. Okay? Now, all I want you to do first of all is draw yourself a grid like I have on the screen here and mark these temperatures on the grid. Okay? Mark these temperatures on the grid. So on the top one, you can see there's a temperature at 15, so put a cross or put a mark at 15. Then there's a temperature at 19, so put a cross or a mark at 19, and so on. Can you do that for me for both of these resorts? Okay, so you should have something that looks like this. Okay, in fact, I've got it on the screen as well. Okay, so literally all I've done is I've just put a point at every single temperature. So I'm kind of building up, if you like, a dot diagram, okay, which we've seen before, right? Now, here's what I want to do. I want to describe the spread of the data in a more informative way. So at the moment, all I've done is I've just plotted a point at every single temperature. And you can start to see some interesting things going on. For example, what would we call this point over here for resort B? An outlier. It doesn't look like it follows the rest of the data. It's kind of outside where the data lies. Okay? Here, it's a bit more spread out, like the data's not really bunched together. So you can start to tell a story, but I want to do it in a more informative way. So one way that I could do this is by splitting the data up into 4 equal parts. Okay? So if I split the data into 4, so split into 4 equal parts, okay, what I could say then is I'm looking at quartiles. Okay, so 4 quarter, yeah? So I'm looking at the 4 equal parts and I'm splitting it in quartiles. So here's what I'm going to do. First of all, I'm going to bound the range of my data. So I'm going to put a mark here and a mark here. So just for resort A, I'll get you to do resort B in just a second. So all I'm doing is just bounding my data, my lowest value and my highest value. Does that make sense?
Why are you going to divide it by 4, not 6?
You could divide it by 6 if you wanted to, okay, but I'm just going for 4.
But is there a generalization?
Not particularly. I mean, you can split it into whatever you like. I just think splitting it into 4 will give you enough information with the least amount of work. Okay, you could split it into 1,000 if you wanted to.
Due to the amount of number you have, the data.
Yeah?
Okay.
Yeah, so I mean, it could be because of that. But to be honest with you, splitting the data into 4 seems personally reasonable. Because then what you can do is look at 25%. You can look at quarters. Yeah? You could split it into 6s, you could split it into 7s, 8s, 9s. You could split it into whatever you wanted to. I just think splitting it into 4 will give you the most information with the least amount of work. Does that make sense? Okay. So first things first, I need to create the bound of my data. This is the start of my data. This is the highest value of my data. Okay, so lowest value and highest value. Okay, so from there, I could work out what my range is. What's my range of resort A? 30, absolutely. Its highest value, 45, take away lowest value, which is 15, that comes out as 30. So I know the range of my data for resort A is 30. Okay? Okay. Well, that's splitting the data, if you like, into 1. If I want to split it into 2, what do I need to find? The median. Yeah, I need to find the median. So I need to split the data into 2. So let's have a look. Where would the median be? Where would the median be?
30.
Let's have a look. So the median value is going to lie at the m plus 1 over 2th value. Okay, absolutely. I'm hearing the right answer. Okay, so let's just make sure we're all there. How many data points have I got? It says in the question. 10, yeah? 10 consecutive data points, right? So therefore, to find the median value, 10 plus 1 is 11, divided by 2, 5.5. It means I'm looking for the value exactly halfway between 5 and 6. Okay, so I'm looking for the 5th value. That's going to be my median. Okay, let's have a look. In fact, it might be easier to look at the screen. Okay, so I go 1, 2, 3, 4, 5. There's my 6th. Halfway between 32 and 34 is 33. Absolutely. So I split it in half. So there's my 32, there's my 34. So there is my median. So I'm going to mark my median on there. Okay, there's my median. So I split my data into 2, 1 and 2. Okay, but I want to split it into 4. So all I need to do is halve these again. Halve these again. Okay, so let's have a look. Have a look on the screen. Okay, if I want to find the halfway point, remember that's my median. That's my median there. Okay, if I want to find the halfway point of my lower half, where is that going to be? Are you happy it's going to be at 20? Yeah? Have a look. If you just look at that lower half, the middle value is going to be 20. Does that make sense to everyone? Yeah. Okay, so let's mark my point at 20 then. Okay, and do exactly the same for the higher one. So there's my higher half, okay, my upper half. So where's my middle value going to be? 40. It's going to be at 40, halfway in the middle again. So I'm going to then mark that on with a straight line. Okay, so are you happy that now I've drawn 5 lines and I've got 1, 2, 3, 4 parts? I've split my data into 4 equal parts. Yeah? Such that what I mean by equal is that we've got the same number of data points in each of these quartiles. Make sense? Yeah? Okay. So therefore, I need to have a look. If there are outliers in my data, where are the outliers going to occur? First quarter, second quarter, third quarter, or fourth quarter? Exactly, the outside ones, outside ones. So what I'm just going to do is I'm just going to join these bars together because they're still part of the data. They're still part of the data, but I'm going to join them together with a horizontal line to show that if there are outliers, they will probably occur in the first and the last quarter. Okay? In which case, I'm left with the middle 2 quarters. Now, these middle 2 quarters should be where the majority of my data lies, where the good data lies, where the most representative data lies. So what I'm going to do is I'm going to put a box around these. I'm actually going to box these together to show that the best data is probably going to lie in here. Does that make sense to everyone? Yeah? Okay. So that's what I've got. I've got myself a box plot. Okay. Just be aware, each one of these is worth 25% of my data. I'm literally splitting the data into 4. Okay. But it's the middle 50%, these 2, which is going to give me the best representative data. Okay, so if you haven't quite finished that, I've put it on the board. Okay, so please make sure that you can at least draw box plots. Okay, so these things are called box plots. Sometimes called box and whisker plots. Okay, because you've got the box and then the 2 whiskers, but box plot is fine. Now, the reason why box plots are really useful is because you can start to make meaningful comparisons between 2 data sets just simply by looking at them against each other. Okay? So remember with box plots, the idea is you're splitting the data into 4 equal parts and then you can make comparisons between 2 data sets. Like if I just asked you to produce a box plot for 1 resort, that wouldn't really tell you an awful lot. Where box plots really come into their own is if you want to compare 2 resorts really quickly and easily. Okay? So when you're making comparisons, here is what you need to really consider. Okay? So which resort would you go to? That's my question to you. Given this data, which resort would you recommend? Now, when you make your recommendation, you need to think about 3 things. You need to think about median. Okay, what does median tell you? What is median a measure of? Exactly, it's an average. So it's an average, yeah? You're happy median is a measure of average. So you can say that on average, which resort is hotter? Resort A or resort B? Resort A, because it's got that higher median. Okay? So really quickly and easily, you can tell which resort is hotter on average. So resort A is. However, you can tell people more than that. Okay, so let me write this down. Okay? So you can say that resort A is hotter on average than resort B. Okay, because it's got that higher median, it's got that higher average. Okay, but you can tell more than just which resort is hotter from a box plot. Okay, because then you can start talking about the interquartile range. Okay, so which resort have the lower interquartile range? The second one, so resort B. Okay, so resort B, okay, has the lower interquartile range. Now remember, interquartile range talks about the middle 50% of your data. In other words, what is the majority of your data doing? What is the most representative data, part of your data doing? Okay? So if it's got a lower value, the range is lower, what does that mean? The temperature difference is smaller. So the most representative data, in other words, the ones without the outliers, is smaller, which means the difference is smaller, which means it's more consistent. Yeah? So have a look. Resort B, you can say the temperatures are more consistent than resort A, or I should say the average temperatures, because it's the middle 50%, are more consistent because the interquartile range is smaller. There's less spread in those middle 50%. Yeah? So resort B is more consistent on average than resort A. Okay? You have to put that on average in there because we're talking about the middle 50%, the most average data, if you like. Okay? We're talking about the data without the outliers, and we're talking about the average data, the most representative data, the middle 50%.